Okay, let us continue our discussion with the program. So, in the last video, I have shown you how to use the function. So, basically, I think if you only give it as here, if you have not given as int and you have only given as input of, and here also you have not given it as int, suppose that. So, this will be taken as string. I think this will be taken as string. Let us check. 12 and 18. Yes, beautiful. So this input of it is taking as string actually. It is taking as string. Okay, that is what I have mentioned in the last video. Either you keep int here or int here, then it will give you the numerical addition instead of string concatenation. Nice. Let us see that. 10 and 20. Very good. Okay. If you keep int here or here while addition, going to return a numerical value. Good. So let us find out, let us write a program to find out the number of digits in a number. In a given number, how many digits are there? So that is the program which I need to write. So how can we write? There is a term called integer division and floating point division. For suppose you have given 5 by, suppose I have given 8 by 5. So this is going to return floating point value 1.6, whereas there is something called integer division where it is going to return double division operator, but it is going to return only before the decimal value, that is called integer division 1. Okay, 0.6 decimal value is neglected. So this thing we are using to get hold of to count how many number of digits are there. There is another operator called modulo operator which gives you the remainder. So if you divide 8 by 5, the remainder is 3, you know that. So let us see that 8 modulo 5. These are arithmetic, what you can say, arithmetic operators in Python. So 8 modulo 5 should return 3. Absolutely 3. So these things remainder is returning. So these things we are going to use to find out some of the very important conclusions that are required to find out number of digits in a program, number of digits in a number. Okay, it is necessary for finding out whether the number is Armstrong or not. How we are going to find out? Suppose we have taken a 3-digit number, suppose that is 150 itself, and initially divide this with 10, divide this with 10, integer division with 10 will return you 15, because it is actually 15.3, is a floating point. Integer division neglects the decimal, so what you are going to get is 15. Okay, so and if you do the modulo operator, what you get is 3. Okay, so until the number is less than 0, you are going to integer divide it with 10. So this will be counted as 1 first iteration. Then if you again divide it with, the 15 is again divided with 10 integer division, it is going to return 1.5, and in which 1 is the fraction, and you can count this as second iteration. You are repeatedly dividing the number with 10. Okay, so you are going to get 1. Then until the number is greater than 0, you are going to divide it. So again you are dividing this 1 with 10, you are going to get 0 now. Okay, and this iteration will be counted as another iteration. Okay, after which it is becoming 0. So if you count the number of possibilities before which the number becomes 0, number of iterations, dividing with repeatedly dividing with 10 will be the number of digits in the number. It will be the number of digits in the number. Okay, so this technique we are employing find out the number of digits in the given particular number. Let us see how it can be implemented in Python code. Okay, so let us define a number. Define, okay, digits underscore number. Okay, that is the function. Let us suppose the number is n, and you can see that you have to write a for loop for I in range of n. Very good. For I in range of n, for loop also followed by colon. So for loop is starting here. Inside the function digits underscore number, we are writing a for loop. So every time you are dividing it with, every time you are dividing the number with 10. Okay, but you can see the number is actually decreasing. So this continues an infinite loop if you run it. So if number greater than 0 only, you are going to do this number greater than 0. Okay, the if condition, and it should be followed by semicolon. Okay, if it is greater than 0 only, you are going to divide it continuously with 10. Okay, then you have to add count variable. Count plus is equal to 1 will increment the count by 1. So first of all, initialize count to be 0. Initially, okay, so it will be repeatedly counting the digits in the number as I have shown iteratively. So this is the for loop start. Okay, and if n is greater than 0, when the n is greater than 0, only going to reduce that number by 10, then go to count, then return the value. Okay, very good. Now it should return some value. This is all in the under function. This is all in the under function. So these are the block of codes that repeat why you call this function. So next, so return. What it must return count. Count gives you the number of digits. Okay. The number can be integer divided. This normal division. The number can be integer divided only. Okay. The number can be integer divided only how many times there are, how many digits are there, that many times only it can be integer divided. That concept we are using. Okay, after which it becomes 0, the number becomes 0. Here the number is n, so it is going to return the value of count. So return printf, return, not printf, print. So it is going to return a print, return count I am writing basically. Okay, so I have to state some value before it for looking good, or for stating what it is. The print of value which